In a 1 liter closed flask, 1 mole of N2O4 is taken and allowed to attain equilibrium at a high temperature. According to the reaction, N2O4 gives rise to 2 moles of NO2. At equilibrium, the degree of dissociation of N2O4 is 0.5. Calculate the value of the equilibrium constant. Initially, only reactants are present. Reactant concentration 1, product concentration is equals to 0. At equilibrium, suppose X amount of the substance is reacted, 1 minus X, 2X. Here what is given? At equilibrium, the degree of dissociation of N2O4 is 0.5. That means 1 minus X value is given 0.5. Based on that X value is 1 minus 0.5 is equals to 0.5. Substitute here 0.5. Then you will get 0.5. 2 into 0.5. 2 into 0.5, 1, 0. Now Kc. What is the Kc formula? Kc formula is product of product concentration by product of reactants concentration. NO2 concentration is 1. 1 whole square by 0.5. 1 by 0.5 value is equals to 2. So second option correct. For an ideal gas in isothermal process, change in temperature remains constant. Change in temperature is equals to 0 and change in internal energy value is also equals to 0. Internal energy change is also equals to 0. That means change in internal energy is constant. Based on that, first option is correct. 200 cm cube of 0.1 molar H2SO4 is mixed with 150 cm cube of 0.2 molar KOH. The quantity of heat evolved is heat of neutralization of strong acid with strong base value is given here. H2SO4 combines with KOH, then it gives salt. Acid plus base combines to give salt plus water. H2SO4 is strong acid, KOH is strong base. First calculate according to the given data number of milli equivalents of acid. Volume is given in terms of ml. Number of milli equivalents. Calculate number of milli equivalents. Number of milli equivalents. Wait. Here given in terms of equivalent. Kilojoule per equivalent. Number of equivalents is equals to normality into volume in terms of liters, or it can be also written as here concentration is given in terms of molarity. Based on that, molarity into n factor, normality place, into volume in terms of liters. Now what is the molarity given? Given molarity is 0.1. 200 cm cube means 200 ml. Converted to liter, 200 cm cube is equals to 200 ml is equals to 0.2 liters into 0.2 into replaceable hydrogen atoms 2. Simplified, then you will get 0.04 equivalents. About base 0.2 into molarity volume 150 ml. 150 ml means 0.15 liters into replaceable OH 1. Then you will get 0.03 equivalents. Based on this, here KOH is acts as limiting reagent. KOH is limiting reagent. Now, for one equivalent, how much amount of heat is liberated? 57 kilojoules. For one equivalent of strong acid and strong base releases 57 kilojoules of heat, then 0.03 equivalents of strong acid and strong base releases how much amount of heat? 0.03 into 57. Simplify, then you will get 1.71 kilojoules. First option correct. Dipole moment of halobenzene is given. Halobenzene dipole moment value is given as 1.5 dB. Then dipole moment of this compound. This is the given compound. First of all, the given compound is which type of compound? Identify. The given compound is symmetrical compound. Why? From this halogen to this halogen, the angle difference is 120 degrees. How? From here to here, the angle is 180 degrees. That means from here to here 60, here to here 120, here to here 180, like that. So, from here to here also 120 degrees. From here to here also, the angle is 120 degrees. Given molecule is symmetrical molecule. Symmetrical molecule. For symmetrical molecule, mu value is equals to 0. Based on this, third option correct. See, one more question is there. Halobenzene dipole moment value is 1.5 dB. Then calculate dipole moment for this molecule. Compound is given as like this. This is the previous year NEET question. Calculate the mu value. This is not symmetrical molecule. This is unsymmetrical molecule. Unsymmetrical molecule, calculate the mu value. Mu value is equals to again 1.5 dB for this compound. How? By using this formula. Mu is equals to square root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Number of 6-membered rings and 5-membered rings in fullerene or Buckminster fullerene. In fullerene, number of 6-membered rings. Number of 6-membered rings is equals to 20. Number of 5-membered rings. Number of 5-membered rings is equals to 12. So this is x value and this is y value. Difference between x and y equals to difference between x and y 20 minus 12, that is equals to 8. Atomic number of carbon atomic number is 6, so first option wrong. Total number of bonds in XeO4, draw the structure of XeO4, double bond O, double bond O, double bond O. 4 sigma bonds are present, 4 pi bonds are present, total number of bonds is equals to 8 bonds. So second option correct option. Halogens are most reactive elements in the periodic table. Regarding the properties of halogen, improper matches. Bond dissociation energy order is given. No, this is only improper match. Bond dissociation energy order. Bond dissociation energy order is chlorine greater than bromine greater than iodine. Once check the atomic properties. Fluorine bond dissociation energy is less compared with chlorine because of small size. Small size of fluorine, then what happened? The lone pair of adjacent fluorine atoms repel each other. That's the reason bond energy decreases. Bond order of H2 plus is equals to H2 minus. This is correct statement. Now once check the MOED diagram, H2 plus MOED diagram. This is the H2 plus MOED diagram. H2 plus contains only one electron. The electron is in bonding orbital. Bond order is equals to NB minus NA by 2. 1 minus 0 by 2, that is equals to 0.5. H2 plus, this is H2 plus, this is H2 plus. Order hydrogen 1s1. Next hydrogen contains empty orbital. This is 1s1. So sigma 1s1, sigma star 1s0. Okay. Now H2 minus. H2 minus, draw the H2 minus MOED diagram. This is the H2 minus. Total number of electrons, 3 electrons are present. 1, 2, 3. Sigma 1s2, sigma star 1s2. Bond order is equals to NB minus NA by 2. That is equals to 2 minus 1 by 2, 0.5. Now stability. Suppose stability, first point. Stability is directly proportional to bond order. If bond order remains same, if bond order remains same, then if bond order remains same, stability depends on number of anti-bonding orbital electrons. Anti-bonding orbital electrons. Stability inversely proportional to number of anti-bonding orbital electrons. So based on this, check which option is correct. H2 minus contains one anti-bonding orbital electron. H2 plus contains 0 anti-bonding orbital electrons. So H2 minus is more stable than H2 plus. Sorry, H2 plus is more stable than H2 minus. But here given H2 plus is equals to H2 minus, this is wrong. Based on that, first option true, second option wrong. Bond angle in H2O 104 degrees 5 minutes is higher than the bond angle of H2S. The difference is mainly due to what we know. First of all, bond angle is directly proportional to S percentage. If S percentage remains same, then bond angle is inversely proportional to number of lone pairs. Suppose if S percentage and number of lone pairs remains same, then bond angle is directly proportional to electronegativity of the centralite. Oxygen is more electronegative than sulfur. That's the reason oxygen H2O bond angle is more compared with the H2S molecule, which is not a disaccharide. Galactose is not a disaccharide. Galactose is a monosaccharide. Acid catalyzed hydrolysis of ethyl acetate is a second order reaction, second order reversible. Wrong. Acid catalyzed hydrolysis, ethyl acetate, that means nothing but ester hydrolysis. Ester hydrolysis is pseudo first order reaction. Order of reaction is always depends on the stoichiometry of the reaction. Wrong. Order of reaction, order is experimentally determined. So both the statements wrong. A dry cell with an EMF of 1.5 volts is vertically cut into two halves. Each piece obtained is made into a dry cell, thus started functioning. The EMF of each of the newly obtained cell in volts is same 1.5 volts. How, sir? EMF of the cell. EMF of the cell, it is a intensive property according to thermodynamics. It is intensive property. That's the reason it does not depends upon weight. The cell potential for the given cell at 298 kelvins cell representation. By using this cell representation, first construct the cell. H2 gas is converted to H plus and Cu2 plus is converted to Cu. Balance the reaction, 2 hydrogens, 2 moles of H plus. EMF of the cell is given 0.31 volts. Cell EMF value is given as 0.31 volts. The pH of the acidic solution is found to be 3. Given pH value is equals to 3, then H plus ion concentration is equals to 10 power minus 3. Whereas the concentration of Cu2 plus is 10 power minus x, calculate the value of x. By using Nernst equation, E is equals to E naught minus 0.0591 by 0.06 you can take directly instead of 0.0591, 0.06 by how many electrons involved? 2 electrons are involved. Log of product concentration by reactant concentration. Ionic forms considered. H plus ion concentration whole square by Cu2 plus. What is given? E value is given as 0.31. E naught value is given as 0.34 minus 0.03, 0.06 by 2 value. Log of 10 power minus 3 whole square by Cu2 plus ion concentration. Simplify now. 0.31 then 0.31 minus 0.34 is equals to minus 0.03 log A by B, log A minus log B, log of 10 power minus 3 whole square minus log of Cu2 plus ion concentration. So here you will get minus 0.03 is equals to minus 0.03 log of 10 power minus 3 whole square. The value is minus 6 minus log of Cu2 plus ion concentration. Now simplify. Minus 0.03. This is 1 is equals to minus 6 minus log of Cu2 plus ion concentration. Then log of Cu2 plus ion concentration is equals to minus 7. Cu2 plus ion concentration is equals to 10 power minus 7. Log Cu2 plus. Then it can be written as 7 is equals to negative log of Cu2 plus ion concentration. If you want Cu2 plus ion concentration, then it can be written as Cu2 plus ion concentration is 7. The isotopic abundance of C12 and C14 is 98% and 2% respectively. What would be the number of atoms of carbon-14 isotope nearly in 12 grams carbon sample? Now, calculate average atomic mass first. Average atomic weight is equals to sigma percentage abundance into atomic mass by 100. That is 98 into 12 in 14. 2 into plus 2 into 14 by 100. Simplify. Then you will get 1176 plus 28 by 100. That is equals to 12.04 grams. Now you know the weight, atomic weight already given. So number of moles is equals to number of moles of carbon is equals to weight by molecular weight. 12.04 divides with 12, nearly 1. 1 mole of any substance contains 6.023 into 10 power 23 number of atoms. Fourth option correct. 10 grams of NaOH dissolved in 10 ml of 5 molar HCl. 10 ml of 5 molar HCl. Excess of HCl is neutralized by 5 ml of 2 molar BaOH twice solution. Percentage purity of caustic soda. First of all, according to the given data, calculate number of millimoles of acid. Number of millimoles of acid is equals to molarity into volume in ml. Simplify. 5 into 10, that is equals to 50 millimoles. Number of millimoles of base. Number of millimoles of base is equals to, so 2 into 5. 2 into 5 into, here acid is HCl, base is BaOH twice. 5 into 2, 5 into 2 is equals to 10 millimoles. Acid is HCl, base is BaOH twice. HCl plus BaOH twice, then it gives BaCl2 plus H2O. 2 chlorines, so 2 moles of HCl, 2 moles of H2O. Now according to this equation, 1 mole of BaOH twice is reacts with 2 moles of HCl. 1 mole of BaOH twice reacts with 2 moles of HCl. And here how many moles of base is there? How many millimoles? 10 millimoles or 10 millimoles. 1 mole, 2 moles. 1 millimole of BaOH twice requires 2 millimoles of HCl. Then 10 millimoles of BaOH twice requires how many moles of HCl? 10 into 2, 20 millimoles of HCl. 20 millimoles of HCl. But here already I calculated a HCl number of millimoles. 50 millimoles is there. But how many millimoles is sufficient? 20 millimoles is sufficient. So This 50 is also written as 20 plus 30. 20 millimoles of acid is sufficient. 30 millimoles of acid is excess. Now, excess of HCl is equals to 30 millimoles. 50 is also written as 20 plus 30. According to the given equation, 20 millimoles of HCl is sufficient. That means 30 millimoles of HCl is excess. HCl. Now, one more reaction. HCl reacts with NaOH. HCl reacts with NaOH. Then it gives NaCl plus H2O. According to this equation, 1 mole of HCl requires 1 mole of NaOH. Otherwise, 1 millimole of HCl requires 1 millimole of NaOH. Here, how many millimoles of HCl is there? 30 millimoles of HCl. Then 30 millimoles of HCl requires how many millimoles of NaOH? 30 millimoles of NaOH. Now, number of millimoles of NaOH, you know, 30 millimoles. 30 millimoles is converted to moles, or it can be written as 0.03 moles. Now we know that moles of NaOH, number of moles is equals to weight by molecular weight. Number of millimoles of NaOH 0.03. Weight, calculate the weight. Molecular weight of NaOH, how much? 40 grams. Then X is equals to 40 into 0.03. Simplify 1.2 grams. But what is the question? Question is percentage purity. Given question is percentage purity. Percentage purity is equals to mass of pure NaOH is 1.2 grams by total mass of the sample is 10 into 100. 1.2 into 100 by 10, then you will get 12%. Correct answer, second option. Percentage purity, formula of percentage purity. Percentage purity is mass of NaOH. Mass of pure NaOH by given mass into 100. Ka of acetic acid is 2 into 10 power minus 5. Buffer action of CH3COOH. CH3COOH is weak acid. CH3COONA is salt of strong base. Buffer is found to be maximum at, remember one point, the buffer action of an acidic buffer. Given buffer is acidic buffer. Acidic buffer is maximum when the concentration of acid is equals to the concentration of the salt. According to Henderson's equation, what we know, pH is equals to pKa plus log of salt concentration by acid concentration. Salt concentration and acid concentration is equal. So pH is equals to pKa. Ka is equals to 2 into 10 power minus 5. pKa is equals to negative log of 2 into 10 power minus 5. 5 log 10 minus log 2. 5 minus log 2 value 0.3010. 4.6990 nearly equals to 4.7. Based on this, second option correct. found to be buffer is found to be maximum if acid concentration is equals to salt concentration, then acidic buffer is found to be maximum. Statement 1, pH of 0.1 molar NH4Cn. NH4Cn is a salt of NH4OH plus HCl. NH4OH HCl combines to give NH4Cn. NH4OH is weak base, HCl is weak acid. Weak acid and weak base. So salt of weak acid and weak base pH value is calculated by using the formula 7 plus 1 by 2 pKa minus 1 by 2 pKb. Based on this formula, according to this formula, pH is independent of concentration of salt. Independent of concentration of salt. First statement correct. NaHCO3 is acidic salt. This is also correct. NaHCO3, sodium bicarbonate, is a acidic salt because it contains replaceable hydrogen. Replaceable hydrogen atom. Regarding normality, which of the following statement is incorrect? Normality is equals to milli equivalent per milliliters. Correct. For same solute, concentration of one normal solution is always less than 1 molar solution. Wrong. This is only wrong. On dilution of solution, normality decreases, but number of equivalents of solute remains same. Correct. Normality is inversely proportional to volume. One normal HNO3 solution contain 1 mole or 1 equivalent of HNO3 in 1 liter solution. Correct. How normality is equals to molarity into N. Only B statement wrong. Which statement is correct? Okay, initial volume is 100 ml. In the first case, volume increases. In the second case, temperature increases. We know that vapor pressure is directly proportional to temperature. Vapor pressure is directly proportional to temperature. According to Clausius-Clapeyron equation, P is equals to A into e power minus e power minus delta H by RT. Vapor pressure is depends upon temperature. Vapor pressure is independent on volume. Not depends upon volume. Vapor pressure is depends only on temperature. Based on that, fourth option correct. 7.483 into 10 power 5 Newton meter power minus 2 osmotic pressure is found for 0.1 molar K suffix X FeCN taken 6 times, which dissociates 50% at 300 kelvins. The value of X is. Calculate the value of X. Okay. Want half factor pi is equals to, if osmotic pressure want half factor is involved, pi is equals to ICRT. Calculate the value of I. First of all, 7.483 into 10 power 5 is equals to I into, what is the concentration? 0.1 molar. R value taken in terms of liters, 0.0821 liter atmosphere mole inverse Kelvin inverse. Temperature 300. Calculate the value of I. Simplify. Then nearly I value you will get 3. I value is 3. Now, what is the question? Question is calculate the value of X. I value will get 1, but calculate the value of X. The relation between want half factor and dissociation is I is equals to 1 plus alpha into n minus 1. Then I value 3, 1 plus 50%, 50 by 100, alpha value 0.5 into n minus 1. Simplify. Then 3 minus 1, 2 is equals to 0.5 into n minus 1. Calculate the value of n. N value is equals to 5. N value, total number of ions is equals to 5. Now you can dissociate this compound Kx Fe Cn taken 6 times. If it is dissociated, because this is degree of dissociation formula, I is equals to 1 plus alpha into n minus 1. It gives x moles of K plus ion plus 1 mole of FeCN taken 6 times minus ion. So total number of ions, total number of moles is equals to x plus 1. X plus 1 value, n value I will get 5. Total number of ions. Equate the terms. 5 is equals to x plus 1. X is equals to 5 minus 1, 4. Fourth option correct. The ratio of number of revolutions of electron per second in second and third orbit of hydrogen atom is, first of all, formula number of revolutions per second. Formula is velocity by circumference. Velocity v, circumference of the circle 2 pi r. Second, in second and third orbit. In case of second orbit, if the orbit is second orbit, then v2 by 2 pi r2. If the orbit is third orbit, then v3 by 2 pi r3. Simplify now. Equation 1 by equation 2. Equation 1 by equation 2 is equals to v2 by 2 pi r2 into 2 pi r3 by v3. 2 pi cancel. v2 r3 by r2 v3. So v2 r3 by r2 v3. Second option correct. An excited electron of hydrogen atom emits photon of wavelength lambda and returns to ground state. Returns to ground state. Returns to ground state means the value of n is equals to 1. The principal quantum number of excited state is given by. Calculate the principal quantum number. Principal quantum number means nothing but n only. Okay, this is taken as n1 value. This is taken as n2 value. Calculate the value of n2. According to Rydberg's equation, 1 by lambda is equals to r into 1 by n1 square minus 1 by n2 square into z square. This is hydrogen atom only. So hydrogen atom z value is equals to 1. Now 1 by lambda is equals to r into n1 value is given as 1. 1 by 1 whole square minus 1 by n2 square. Simplify. Now 1 by lambda r is equals to 1 minus 1 by n2 square. Then 1 by n2 square is equals to 1 minus 1 by lambda r. Now simplify. 1 by N2 square is equals to lambda R minus 1 by lambda R. N2 square is equals to lambda R by lambda R minus 1. N2 is equals to square root of lambda R by lambda R minus 1. So, fourth option correct. For a zero order reaction, the initial amount of reactant is 100 grams and its half-life is 20 minutes. The amount of reactant left after 40 minutes will be. Half-life value is given. What is the formula? T of is equals to 0.693 by K. By using half-life, calculate the value of K. 0.693 by 0.693 by 20. No, not like this. It is given as zero order reaction, not first order reaction. This is a zero order reaction. Sorry. Given zero order reaction. T of is equals to R naught by 2K. Then K is equals to R naught by 2 into T of. What is the R naught? Initial concentration is given as 100 by 2 into T of value is 20. 100 by 40, 100 by 40 will get 2.5. 2.5 gram minute inverse. Now, integrated rate equation of zero order reaction. Integrated rate equation of zero order. Integrated rate equation of zero order. K is equals to R naught minus R by T. K value calculated 2.5. R naught value 100. R value calculate. Time is given as 40. Simplify. 40 into 2.5. 100 is equals to 100 minus R. R is equals to 0. First option correct. Match the following. A. Brown ring complex. Brown ring test. A2. Only one option is there. So, here remember Brown ring complex. Brown ring complex. Formula is FeH2O taken 5 times NOSO4. In Brown ring complex, iron exhibits +1 oxidation state. Iron exhibits +1 oxidation state. Next, CrO2Cl2. CrO2Cl2 chromyl chloride. Chromyl chloride test. Chromyl chloride. Chromyl chloride test. Chromyl chloride reacts with base. Then it gives sodium chromate Na2CrO4. Na2CrO4 is yellow color solid. Color is. Next, NH4OH plus HCl. NH4OH plus HCl. Then it gives NH4Cl, ammonium chloride. Ammonium chloride, which appears white dense fumes. FeS plus H2SO4. It gives H2S gas. H2S is rotten egg smell. N-hexane. N-hexane is heated with MO2O3, 500 degrees Celsius, 10 to 20 atmosphere. Then it gives benzene. Aromatization process. Alkane properties. Once check the alkane properties. N-hexane, carbon atom undergoes sp3 hybridization. Here carbon atom undergoes sp2 hybridization. Between carbon and carbon, single bond is present. Here double bond is present. Based on this, once you can check. Hybridization of carbon changes, correct. Number of CC bonds increases. C single bond C increase. Number of CC bonds increases. Number of CC bonds increases, correct. N-hexane 1, 2, 3, 4, 5, 6. How many CC bonds are present? 1, 2, 3, 4, 5 CC bonds are present. So here between carbon and carbon 1, 2, 3, 4, 5, 6. Number of CH bonds decreases. Here 16 CH bonds are present, but here how many CH bonds are present? 6 CH bonds are present, correct. Percentage of carbon increases, correct. First option. Incorrect statement from the following is, first one, benzaldehyde. Benzaldehyde is a aromatic aldehyde. It gives positive Tollens reagent test but negative Fahrenheit reagent test because it is aromatic aldehyde. Which of the following will have the least hindered rotation about carbon-carbon bond? Alkenes, ethane. Determine which of the following statement about valency bond theory in complexes is incorrect. It does not explain the color of coordination compounds. This is correct only. It can distinguish between strong and weak ligands. This is incorrect statement. Not can. It cannot distinguish. Identify A in the above reaction. A in the above reaction. Take ethane nitrile CH3C triple bond N reacts with Grignard reagent CH3MgBr. Then break the bond between carbon nitrogen, nitrogen negative, carbon positive, negative positive, negatively charged carbon moves towards positively charged carbon CH3C CH3 double bond N MgBr. Which on further hydrolysis? Then it gives CH3 CO CH3 ketone. Now ketone reacts with dilute NaOH. Ketone reacts with dilute NaOH. Which reaction takes place? This is aldol condensation reaction. Take CH3 C double bond O CH3. Another mole also you can take CH2H CO CH3. Aldol condensation, further heating, it loses water molecule. First compound loses oxygen, second compound loses 2 alpha hydrogens. Then it gives CH3C CH3 double bond CH single bond CO CH3. So based on that, ethane nitrile, correct answer. The incorrect statement among the following is, the first ionization enthalpies of lanthanides are nearly 600 kJ per mole, correct. Both neptunium and plutonium exhibits maximum oxidation state +7, correct. The transition metal present in Ziegler-Natta catalyst is titanium, correct. Europium has smallest atomic radius. This is wrong. Europium atomic radius is largest atomic radius. Only D is incorrect. Identify C. First of all, given alkene reacts with HBr peroxide. HBr peroxide is given. Peroxide is present. Then it follows anti-Markovnikov's rule. Anti-Markovnikov's rule. Add hydrogen atom from HBr to unsaturated carbon which contains less number of hydrogens. Then it gives CH3CH2 CH2 Br. Next, use alcoholic KOH. Dehydrohalogenation takes place. Alcoholic KOH dehydrohalogenation. Then it gives CH3 CH2. Hydrogen you can remove. Okay, CH3 CH double bond CH2. After that add HBr. Addition of HBr in the absence of peroxide. It follows Markovnikov's rule. Then it gives CH3 CH Br CH3. Again reacts with alcoholic KOH. Again reacts with alcoholic KOH. Sorry, here I forgot to write one more carbon. CH3 CH2 CH2 1 2 3 4. Okay, 1 2 3 4 CH2 Br. You can remove. Then it gives CH3 CH2 CH double bond CH2. Now follows Markovnikov's rule. Then it gives CH3 CH2 CH Br CH3. Now alcoholic KOH dehydrohalogenation again. SAGEF product is major product. SAGEF major product. If you want major product to remove hydrogen atom from beta carbon which contains less number of hydrogens. This beta carbon contains less number of hydrogens. Then CH3 CH double bond CH CH3. Which one reacts with Br2 by CCl4? Br2 by CCl4 favors addition reaction. Addition reaction it favors. Add bromine atoms. Then CH3 CH Br CH Br CH3. Now reaction with 2 moles of NaNH2. Sodamide. Again sodamide is acts as a dehydrohalogenating agent. Then it gives 2 times remove hydrogen halogen 2 times. Then it gives CH3 C triple bond C CH3. U2 fourth option correct. Which of the following complex absorbs maximum wavelength in the visible region? According to crystal field theory, E is equals to Hc by lambda. Energy is inversely proportional to wavelength. Maximum wavelength, less crystal field splitting energy. Now, crystal field splitting energy is directly proportional to spectrochemical series order. Spectrochemical series order, according to that, the order is Cn minus greater than, NH3 greater than, H2O greater than, F minus. Fluorine crystal field splitting energy is less, so wavelength is more. Benzene cannot reacts with Bayer's reagent Br2CCl4 HBr. Chlorine iron dark, yes, reacts, then it gives chlorobenzene. In the presence of benzene reacts with chlorine in the presence of sunlight, then it gives benzene hexachloride. Yes, reacts with chlorine, no, cannot reacts with ABC. Second option. Paper chromatography is a type of partition chromatography, correct. Nitrogen present in azobenzene cannot be detected by Lassen's test, but cannot be estimated by Geldahl's method. Correct. Both the statements are correct. Remember, cannot be estimated by Geldahl's method. By using Geldahl's method. Geldahl's method is not applicable. for nitro NO2, nitroso NO, azo N double bond N, azoxy N double bond N, coordinate covalent bond O, pyridine and quinoline. Not applicable for this compound. What is the reason? Because nitrogen present in these compounds is not quantitatively. Nitrogen present in the compound quantitatively converted to ammonium sulfate. Identify B in the reaction. This is ether. Ether reacts with HI, follows SN2 mechanism, and it gives oxygen minus, carbon plus, H plus, I minus. Then it gives one alcohol form. The alcohol is CH3CH2, CH, CH3, CH2, OH. It's concentrated H2SO4. Dehydration takes place. First of all, OH group attached carbon, adjacent carbon is 3 degree carbon. So here hydride shift takes place. Hydride shift is possible. How? First of all, remove OH minus, then it gives CH3CH2, CH, CH3, CH2 plus. The carbocation, formed carbocation is 1 degree carbocation. 1 degree carbocation is least stable. So hydride shift takes place. Then it gives CH3CH2, C, CH3, CH3, positive charge. Now remove hydrogen. Dehydration. Which product, major product? SAGEF's product. SAGEF product. Remove hydrogen atom from beta carbon which contains less number of hydrogens. Then you will get CH3CH, double bond C, CH3, CH3. Based on that, second option correct. Identify the incorrect statement. Decreasing order of acidic nature is given. N2O5 greater than, CO2 greater than, B2O3 greater than, BeO greater than, Li2O. First of all these are the same period elements. Periods left to right, acidic nature increases. So this is correct statement because same period elements. Among Na plus and F minus, the smallest ion is F minus. Wrong. Smallest ion is not F minus. Smallest ion is Na plus. Because in case of isoelectronic species, this is isoelectronic. In case of isoelectronic species, size is directly proportional to negative charge. Helium is used as a diluent for oxygen in modern diving operators because of its very high solubility in blood. No, not very high solubility. This is very low solubility in blood. Atomic size of yttrium is equals to lanthanum. No, not yttrium is equals to lanthanum. B, C, D are wrong. Complete the following reaction. First of all, this OH group is directly attached to benzene ring. This is phenolic OH group. Phenolic OH group is unaffected by SOCl2. This is not benzene ring. So this is considered as alcoholic OH group. This is also considered as alcoholic OH group. Phenolic OH groups not affected by SOCl2. That is, only alcoholic OH groups are affected. Alcoholic OH groups are affected. Based on that, alcoholic OH place substitute chlorine. Match the following. Schwarz reaction. Ethyl iodide. Not ethyl iodide. Schwarz reaction. Schwarz reaction. Schwarz reaction ethyl fluoride. A4. A4 only one option is there. Sandmeyer reaction. Sandmeyer reaction ethyl benzene. Fittig reaction. No. Sandmeyer reaction. Sandmeyer reaction gives chlorobenzene. A4. This is given wrong option. Change like this. A4 B3. Sandmeyer reaction chlorobenzene. C. Wurtz-Fittig reaction. Wurtz-Fittig C1. Finkelstein reaction D2. Ethyl iodide. Boiling points of alkyl chlorides, bromides and iodides are considerably higher than those of hydrocarbons. Comparable molecular masses. Correct. Intermolecular forces of attractions are stronger in halogen derivatives than hydrocarbons. Correct. So both A and R are true, and R is the correct. R is the correct explanation of A. Both are printing mistake. R is the correct explanation of A. E2 of iron is lower than IE3 of manganese. Correct. Fe2 plus has 3d6 configuration. Mn2 plus has 3d5 configuration. Both A and R are true, and R is the correct explanation of A. And benzoic acid can be distinguished by NaOH. Wrong. It can be distinguished by sodium bicarbonate, NaHCO3. Sodium bicarbonate test. Benzoic acid is stronger acid than phenol. Correct. A false, but R is true. Stability of vinyl cation. Vinyl cation formula CH2 double bond CH plus. Allyl cation formula CH2 double bond CH single bond CH2 plus. Which is more stable? This is vinyl. This is allyl. Allyl is more stable. Based on that, first statement wrong. Why? Positive charge and more electronegative carbon. In case of vinyl, positive charge is present on more electronegative carbon. That's the reason unstable. The IUPAC name of the compound 3-chloroheptacene 3-chloroheptacene. Correct. Statement 1 incorrect, but statement 2 correct. Which of the following vanadium dihalide is unstable? Which is unstable? VF2 is unstable. Once check the D block elements. Halides table. Calculate the percentage of phosphorus. Percentage of phosphorus is equals to 62 by 222 into weight of Mg2P2O7 by weight of organic compound into 100. Simplify 62 by 222 into weight of Mg2P2O7 0.222 by 0.12 into 100. Simplify, you will get 51.66. Third option correct. The element with atomic number 111, rhonginium Rg. Aniline reacts with acid anhydride, then it gives NHCOCH3 acetamide. Acetamide reacts with bromine, then substitute para position bromine NHCOCH3, substitute bromine at para position, which on further hydrolysis, then it is converted to NHCOCH3 is converted to NH2, which is reacts with NaNO2 plus HCl. Then diazotization process takes place. Then it gives C6H5N2Cl bromine, which on further reacts with HBr, CuBr. Sandmeyer reaction takes place. Then substitute bromine. So based on that, first option correct option. Thank you.